Hello viewers, welcome to IIT PAL Mathematics channel. This is lecture 4 on integral calculus. So, we will continue doing some more problems. So, let us start with problem number 1. This says that let S be the area of the region bounded by y equal to e to the power minus x square, y equal to 0, x equal to 0 and x equal to 1. Then which of the following options are correct? A is S is bigger than equal to 1 by E, B is S is greater than equal to 1 minus 1 by E, C is S is less than equal to 1 by 4 times 1 plus 1 by square root of E, and D is S is less than equal to 1 by root 2 plus 1 by square root of E times 1 minus 1 by root 2. So, let us try to solve this problem. So, let us first draw the region. We have xy axis and the graph of y equal to e to the minus x square. This looks like this, and at x equal to 0, the value is 1 and it keeps on decreasing as x increases. So, this region is the area bounded by this curve. Y equal to 0 is the x axis and x equal to 0 is the y axis and x equal to 1. So, this is the region area of this region is given to be equal to S. Now, if we see what is this value. So, at x equal to 1, e to the minus x square will give 1 by e. So, this point is 1 comma 1 by e. So, clearly we can see that this area is bigger than equal to area of this rectangle, which is equal to 1 by e times this is 1. So, area S is bigger than equal to area of rectangle. Let us call this point A, B, C, O, A, B, C, which is equal to 1 times 1 by E. So, S is bigger than equal to 1 by E is clearly correct. So, A option is correct. Now, B says S is bigger than equal to 1 minus 1 by E. So, if we see e to the minus x square, if we compare e to the minus x square with e to the minus x, then we see that e to the minus x square is bigger than equal to e to the minus x for all x between 0 to 1. This is because x square is less than equal to x for x in 0 1. So, e to the minus x square will be bigger than equal to e to the minus x. So, therefore, the integral of 0 to 1 e to the minus x square dx, this is bigger than equal to integral of 0 to 1 e to the minus x dx, and this integral is nothing but 1 minus 1 by e. So, therefore, option B is also correct. So, this option A and option B are both correct. Now, we have to see option C and option D. So, here we have to find whether S is less than equal to something. So, again we should try to see if we can see this to be less than equal to some area. If we see option D, we have S is less than equal to 1 by root 2 plus 1 by square root of e times 1 minus 1 by root 2. So, if we draw this, this is 1 0. If we look at the point 1 by root 2, then 1 by root 2 is the area of this rectangle, is 1 by root 2 times height is 1. And what about this rectangle? So, this point, the value at 1 by root 2 will be 1 by root 2 comma y is e to the minus x square. So, that will be e to the minus half. So, this height is equal to 1 by square root of e. So, by the figure, we see that S is less than equal to sum of area of these two rectangles. So, area of the first rectangle is 1 by root 2 plus the area of the second rectangle is height is 1 by square root of e times 1 minus 1 by root 2. So, that is our option D. So, A, B and D are correct. Let us try to see if C is correct or not. So, C option is saying that S is less than equal to 1 by 4 times 1 plus 1 by square root of e. We have already seen that S is greater than equal to 1 minus 1 by e. So, let us try to see whether this quantity is less than or bigger than 1 minus 1 by e. So, if we see, one minus 1 by e minus 1 by 4 times 1 plus 1 by square root of e, this is in option C. So, this is equal to 1 minus 1 by 4, that is 3 by 4 minus 1 by e minus 1 by 4 square root of e, which is equal to 1 by 4 e times 3 e minus 4 minus square root of e. Now, we know that e is between 2 and 3, e is approximately 2.71. So, we can use this to see that 3 e minus 4 minus square root of e, this will be bigger than 3 times 2 minus 4 minus square root of 3. So, this is equal to 2 minus square root of 3. which is clearly bigger than 0. So, therefore, we see that this difference is bigger than 0. So, therefore, 1 minus 1 by E is bigger than 1 by 4 times 1 plus 1 by square root of E. So, since S is bigger than equal to 1 minus 1 by E, you will have S is bigger than 1 by 4 times 1 plus 1 by square root of E. So, therefore, option C is wrong. So, this says that options A, B and D are correct and C is wrong. So, here you should note that this integral e to the minus x square dx from 0 to 1, it is not possible to evaluate it exactly. So, therefore, you have to use these inequalities, you cannot calculate the exact value of this integral. Now, let us move to second problem. So, suppose f is given to be a function from the closed interval half 1 to 0 infinity. Let this be a non-constant differentiable function such that f prime of x is strictly less than 2 times f x and f at half is equal to 1. Then the value of integral of f x dx from half to 1 lies in the interval option A is 2e minus 1 to 2e, B is e minus 1 to 2e minus 1, C is e minus 1 by 2 to e minus 1 and D option is 0 to e minus 1 by 2. So, let us try to solve this problem. So, what we are given is f prime x is less than 2 times f of x. So, f prime x is less than 2 times f x. This implies f prime x minus 2 f x is strictly less than 0. This is for all x in half to 1. Now, what we can do is we multiply this by e to the power minus 2 x. So, e to the minus 2 x times f prime x minus 2 f x. We know that exponential is always positive. So, this will also be less than 0. Why we multiplied by e to the minus 2 x? Because by doing this we see that this can be written as d by dx of e to the minus 2 x times f x, because by product rule this is e to the minus 2 x times derivative of f is f prime x plus derivative of e to the minus 2 x will give minus 2 e to the minus 2 x times f x. So, that gives you this. So, this is less than 0 for all x in half to 1. Now, we know that if the derivative of function is negative in an interval, then this implies that e to the minus 2x times f x is a decreasing function in the interval half to 1. So, therefore, e to the minus 2x f x will be strictly less than e to the power minus 2 times half times f at half for all x greater than half. So, f of half is given to be equal to 1. So, this is equal to 1 by e, which implies f of x is less than e to the power 2x minus 1 for x in half to 1. So, if f x is less than a function g of x, then this will imply integral half to 1 f x dx is less than integral of half to 1 e to the 2x minus 1 dx, and this is equal to e to the 2x minus 1 by 2 from half to 1, which is equal to, at x equal to 1, this will give e by 2, and at x equal to half, it is e to the 0 is 1 by 2. So, this is e minus 1 by 2. So, therefore, this integral half to 1 f x dx, this is strictly less than e minus 1 by 2. Also, since f x is greater than 0, integral half to 1 f x dx, this will be bigger than 0. So, therefore, this lies between 0 and e minus 1 by 2. So, this option D is correct, and all the other options you can see are wrong, because this integral is less than e minus 1 by 2. So, option C is wrong. Similarly, option B is wrong and option A is wrong. So, note that in this solution we do not need to use that f is a non constant function, but this is given in the problem, because if it was not specified that f is non constant, then you can take f to be the constant function, because f of half is given to be equal to 1. We can take f x equal to 1 for all x in this interval, that satisfies f prime x will be 0, which is less than 2 times f x, and in that case this integral, because f x is equal to 1, this is simply equal to half, and half clearly lies between 0 and e minus 1 by 2. So, one can easily get that option D is correct, but if we are given that f is non constant function, then we cannot be sure that this is correct unless we solve this. Now, let us move to question number 3. Let f x and g x be non constant differentiable functions on R such that f prime of x is equal to e to the power f x minus g x times g prime x for all x in R, and f of 1 equal to g of 2 equal to 1. Then a f of 2 is less than 1 minus natural log of 2, b is f of 2 is bigger than 1 minus log 2, c is g of 1 is bigger than 1 minus log 2, and d is g of 1 is less than 1 minus log 2. So, we are given f prime x is equal to e to the power f x minus g x times g prime x. So, this implies e to the minus f x times f prime x is equal to e to the minus g x times g prime x. But here this is nothing but derivative of e to the power minus f x, and this is derivative of e to the minus g x. So, what we have is derivative of this is equal to derivative of this for all x. This implies e to the minus f x is equal to e to the minus g x plus some constant for some constant c. Now, we are given the value of f of 1 is 1 and g of 2 is 1. So, we will use those. So, therefore, e to the power minus f of 1 will be equal to e to the minus g of 1 plus c. F of 1 is given to be equal to 1. So, this implies e to the minus g of 1 plus c is equal to e to the minus 1, and e to the minus f of 2 is equal to e to the minus g of 2 plus c. G of 2 is 1. So, this is e to the minus 1 plus c. So, we get these two equations. We do not know the value of c. So, we can eliminate c from these two equations. So, from 1 and 2, we have c is e to the minus f of 2 minus 1 by e from 2. This is equal to 1 by e minus e to the minus g of 1. So, this implies e to the power minus f of 2 plus e to the power minus g of 1 is equal to 2 by e. Now, we know that exponential this is always positive. So, this implies e to the minus f of 2 is strictly less than 2 by e, and e to the minus g of 1 is also strictly less than 2 by e. So, this implies e to the f of 2 is bigger than e by 2, and e to the g of 1 is bigger than e by 2. Then by taking log, f of 2 will be bigger than log e by 2, which is log e is 1 minus log 2, and similarly g of 1 is bigger than 1 minus log 2. So, option B, f of 2 bigger than 1 minus log 2 and g of 1 bigger than 1 minus log 2, these are correct, and A and D are wrong. Again, you should note that if in this question it was not given that these are non-constant functions, then you can take f and g to be the constant function 1, and then clearly this equality is satisfied because both sides are 0. So, in that case f of 2 will also be equal to 1 and g of 1 will be 1, and which is clearly bigger than 1 minus log 2. So, you can easily get option B and C without doing any work. Let us now do problem number 4. We are given g of a equal to integral from 0 to 1 t to the power minus a times 1 minus t to the power a minus 1 dt for a belonging to open interval 0 to 1. Also, it is given that g is differentiable on the open interval 0 1, then find the values of g at half and derivative g prime at half. So, first let us try to find g of half by putting a equal to half. G of half will be integral of 0 to 1 t to the power minus half times 1 minus t to the power a minus 1 is again minus half dt. This is equal to integral from 0 to 1 by square root of t times 1 minus t dt. Now, this can be written as integral from 0 to 1 by square root of, we have t minus t square inside square root. So, this can be written as 1 by 4 minus t minus half square dt. 1 by 4 will cancel and we will get minus t square plus t. Now, this we know is nothing but sine inverse of t minus half divided by half evaluated between 0 and 1. So, for t equal to 1, this will be sine inverse of half by half. So, sine inverse of 1 minus sine inverse of, at 0 it is minus 1. So, this is equal to pi by 2 minus pi by 2. So, that is equal to pi. So, therefore, g at half is equal to pi. Next, we have to calculate the value g prime at half. So, there are two ways of doing. One is we can try to differentiate this g of a and then put a equal to half, and another way is to notice that let us calculate what is g of 1 minus a. G of a is given to be equal to integral from 0 to 1 t to the minus a 1 minus t to the power a minus 1 dt. So, therefore, g of 1 minus a is equal to 0 to 1 t to the power minus of 1 minus a and 1 minus t to the power a is replaced by 1 minus a minus 1 dt. So, this is equal to integral from 0 to 1 t to the power a minus 1 and 1 minus t to the power minus a dt. Now, this is same as integral of 1 minus t to the power a minus 1 and t to the power minus a dt from 0 to 1. This is because integral of a to b f x dx is same as integral of a to b f of a plus b minus x dx. So, now this is equal to g of a. So, therefore, we have got that g of a is equal to g of 1 minus a for all a in 0 to 1. So, by differentiating we get g prime of a is equal to minus g prime at 1 minus a. Now, we can put a equal to half, we get g prime of half is equal to minus g prime of half. This implies g prime half must be 0. So, the value of g prime half is equal to 0. Another way to calculate this g prime of half is we have g of a is equal to integral 0 to 1 t to the minus a 1 minus t to the a minus 1 dt. This implies g prime of a will be equal to integral of 0 to 1 the partial derivative with respect to a of t to the minus a 1 minus t to the a minus 1 dt. Now, we can calculate this derivative with respect to a of the integrand, that is equal to minus t to the minus a log t 1 minus t to the a minus 1 plus t to the minus a 1 minus t to the a minus 1 and log 1 minus t dt. And now, if we put a equal to half, we see that this is equal to 0 at a equal to half. Therefore, g prime at half is equal to 0. Okay, let us do question number 5. So, we have to find the value of integral from 0 to 1 4 x cube times the second derivative of 1 minus x square raised to power 5 dx. So, one direct way is first calculate this second derivative, and then integrate. But if you see, this will involve lot of computations. So, this will be a lengthy process, because we have to take derivative 2 times of this, then multiply by 4 x cube, then integrate it. So, that will be a huge polynomial, and this will take too much time. So, a smarter way is to use integration by parts formula. So, let us recall integration by parts formula. So, we have if we write integral of f x times g prime x dx, this is equal to f x times g x minus integral of f prime x g of x dx. Or there is another way, if we have two functions f x and g x multiplied together, then this integral will be f x times you integrate the second function g x dx minus integral of you differentiate the first function f prime x and integrate the second function g x dx, and then you integrate it. So, we will use this formula. So, let us write f x is equal to 1 minus x square to the 5. Then we have to calculate integral of 0 to 1 of 4 x cube times f double prime x dx. So, by integration by parts formula, this is equal to 4 x cube times, if we see f double prime x is derivative of f prime x. So, this is equal to f prime x from 0 to 1 minus integral of 0 to 1, the derivative of 4 x cube will give 12 x square times f prime x dx. Now, this we can again use integration by part. So, this is 4 x cube f prime x from 0 to 1 minus this will be 12 x square times f x from 0 to 1 minus integral 0 to 1 of 12 x square, when we differentiate we get 24 x times f x dx. Now, since f x is equal to 1 minus x square to the 5, what is f prime at 1? This will be equal to 0, because you can differentiate this and then put x equal to 1, you have 1 minus x square factor. So, that will be equal to 0, or you can notice that x equal to 1 is a repeated root of this function f of x, and therefore, f prime 1 must be equal to 0. So, therefore, this part is equal to 0 at 1, and at x equal to 0 we have 4 x cube term. So, this is 0. Similarly, f of 1 is also 0. So, this part is also equal to 0, because f of 1 is 0 and at 0 we have x square term. So, therefore, this thing is nothing but 0 to 1 4x cube times f double prime x dx is equal to 24 times integral 0 to 1 x times fx dx. So, this is equal to 24 0 to 1 x, fx is 1 minus x square to the power 5 dx. Now, this can be easily integrated. So, this is equal to, if we put 1 minus x square equal to y, then we get minus 2 x dx is dy, then this is nothing but 12 times integral 0 to 1 y to the 5 dy, which is equal to 2 y to the 6 from 0 to 1, and this is equal to 2. So, this can be easily integrated. So, therefore, the answer is the value of the integral is equal to 2. Let us do question number 6. If I sub n denotes this definite integral from minus pi to pi of sine of n x divided by 1 plus pi to the power x times sin x dx for n equal to 0, 1, 2 and so on. For every non-negative integer, we have defined I n to be this integral, then which of the following options are correct? A is I n equal to I n plus 2 for all n, B summation of I 2m plus 1 for m equal to 1 to 10, this is equal to 10 pi, C summation I 2m for m equal to 1 to 10 equal to 0, and option D is I n equal to I n plus 1 for all n. So, we are given this integral I n. This is integral from minus pi to pi of this thing. So, we know that this will be equal to integral of 0 to pi of sin n x by 1 plus pi to the x times sin x. This is f of x plus f of minus x, it will be sin of minus n x by 1 plus pi to the minus x times sin of minus x dx. This is because integral minus a to a of f x dx is nothing but integral 0 to a of f of x plus f of minus x dx. Now, if we add these two, you see that I n is nothing but integral 0 to pi of sin n x by sin x dx. The other thing adds to 1. So, we get this. Now, clearly we can calculate if we put n equal to 0, I 0 is equal to 0 because sin 0 is 0, and also I 1 we can easily calculate. I 1 will be integral 0 to pi sin x by sin x dx. This is simply equal to pi. So, clearly this shows that I n is not equal to I n plus 1 for n equal to 0. So, option D is wrong. I 0 is not equal to I 1 implies D is wrong. Now, let us compare I n plus 2 with I n. So, if we look at I n plus 2 minus I n, this will be integral 0 to pi for n plus 2, this will be sine of n plus 2 x minus sine n x divided by sine x dx. Now, we can use the formula sine c minus sine d. So, this is equal to integral of 0 to pi 2 cos c plus d by 2. So, that is n plus 2 plus n is 2n plus 2 divided by 2. So, that is n plus 1 x times sine c minus d by 2. So, n plus 2 x minus n x will give sine 2 x by 2 will give sine x divided by sine x dx. So, sine x cancels and this is simply 2 times sine n plus 1 x divided by n plus 1 between 0 and pi, which is equal to 0 because sine at any integer multiple of pi is 0. So, therefore, I n plus 2 is equal to I n for all n. So, that is option A is correct. Now, we also get B and C. So, since we have already seen that I 0 is 0, we have I 2 m equal to 0 for all m, and I 1 is equal to pi. So, I 2 m plus 1 is equal to pi for all m. So, therefore, if we see option B, summation of I 2 m plus 1 for m equal to 1 to 10, each I 2 m plus 1 is pi. So, this will give 10 pi. So, this is correct, and I 2 m is 0 for all m. So, therefore, the sum is also 0. So, A, B and C are correct. So, let us do one more problem. Question number 7. The total number of distinct x in 0 1 for which integral of 0 to x t square by 1 plus t to the 4 dt is equal to 2 x minus 1 is what? So, we have to find the number of x for which this integral is equal to 2 x minus 1. So, let us write f x equal to integral of 0 to x t square by 1 plus t to the 4 dt minus 2 x minus 1 for x belonging to 0 1. So, clearly f is continuous and differentiable function Also let us see what is the value of f of 0. If we put x equal to 0, the integral is 0 to 0. So, this is 0 minus this will be minus 1. So, this is equal to 1. So, f of 0 is positive, and if we put x equal to 1, then f of 1 is equal to integral 0 to 1 t square by 1 plus t to the 4 dt minus 2x minus 1 at x equal to 1 is 1. So, we have this integral minus 1. Now, for t between 0 and 1, t square by 1 plus t to the 4 is strictly less than 1. So, therefore, integral 0 to 1 t square by 1 plus t to the 4 dt, this will be less than 1, and therefore, f of 1 is the difference is negative. So, we have f is a continuous function, f at 0 is positive and f at 1 is negative. So, by the intermediate value theorem, for continuous function, we know that there exists at least one x in the interval 0 to 1 for which f x is equal to 0. So, we know that the number of x for which this integral equal to 2x minus 1 is at least 1. Now, let us see if we can have more than 1. So, now what is f prime of x? So, f x is integral of this minus 2x minus 1. So, if we differentiate this, f prime x will be x square by 1 plus x to the 4 minus 2. Now, we know that x square by 1 plus x to the 4 is strictly less than 1. So, this is less than 1 minus 2, which is minus 1. So, f prime x is less than 0. This implies f is strictly decreasing in the interval 0 to 1. So, f is strictly decreasing function, which means that f cannot have more than 1 zeros. So, this implies f can have at most 1 0 in 0 1. So, we got that f has at least 1 0 in this interval, and this says that f has at most 1 0. So, therefore, the number of x for which f x equal to 0 is 1. So, that is the answer to this problem. So, this finishes lecture 4 on integral calculus. In the next lecture, we will do some more problems. Thank you.